Welcome to Applied Stats, looking at the practical applications and how you can go about doing your calculation. On this section, we're looking at discrete probability distribution. Specifically, we're going to deal with the binomial probability distribution, and then the other videos will look at the Poisson, and then would move into the normal probability distribution and move into the other topics. A probability distribution is a list of all possible outcomes of a random variable and their associated probabilities of occurrence. So essentially, we have looked at how to calculate probabilities using empirical means, where we had to do a sample and we had to calculate probabilities. Now we're moving into how to actually use mathematical functions or a table or a formula or a function to calculate probabilities, because we have some known probability patterns that we're dealing with. When you look at the random variables that we're going to study, we're going to mainly focus on what we call discrete random variables, or the random variable could be continuous. And so we can see that on the discrete random variable, the information can be presented in kind of like a graph, and the graph has on individual bars. It's not like a histogram, which is continuous data, but it's like bars just representing probabilities that can occur at a different point. The continuous one would have everything under like a table. Discrete random variable is given by a table listing all possible values for the random variable along with the corresponding probabilities. The appropriate chart to display it is a bar chart, unlike a histogram. Binomial probability distribution, it follows four conditions. So the first condition is that the random variable is observed n number of times. So in your questions, you always be given the number of times you're observing a certain thing. That will be your n. There are only two mutually exclusive and collectively exhaustive events, meaning to say that we'll always have either success or failure. Success is what you'll be required to test, and failure would be what is the other side of the coin. For example, if I say I want a head, the head is the success, the failure becomes the tail. And if we look at the other condition, each outcome has an associated probability. What is the probability of tossing and getting a head? It's 50%. What is the probability of tossing and getting a tail? It's 50%. So we can say the probability of success is denoted by P. The probability of failure is denoted by 1 minus P, meaning to say if I have a head of 50% or 0.5, the tail is going to come out to be calculated by saying 1 minus 0.5, which gives me the 0.5 still. Just like if I say the probability that it will rain is my success, and it's 20%. The probability that it doesn't rain, which is the probability of failure, would be 1 minus 20%, which gives me the 80%. The objects are assumed to be independent of each other, meaning that P remains constant for each sampled objects of any other objects, meaning to say that the P would not change. The probability of raining would just remain 20% for that given scenario. So looking at binomial probability distribution, the formula would be given by saying Px is equals to ncx multiplied by P to the power of x, 1 minus P to the power of n minus x. And this is normally to a given number of observation. N would be the sample size, and x is the number of successes in the n independent drawn object, and P would represent the probability of what we're looking for, which we call the success outcome, and 1 minus P would be the probability of failure. Sometimes it's not given, you just have to wait. Welcome to the calculation. So we're looking at probability distributions, and we are first going to go into what we call binomial probability distribution. So this is binomial probability distribution. Right. We looked at the properties of binomial probability distribution. So when we read the question, we should be able to pick up that this is a binomial question and then start to identify the variables that we need, and we go ahead and we write them out, and then we start our calculations. So a company in Essentia has in the long term established that they have a 40% chance of making a sale when calling a customer. If the company arranges for 8 calls, what is the probability of making exactly 3 calls? Number B, what is the probability of making fewer than 3 calls? What is the probability of more than 3 sales? Calculate the mean for this distribution. Calculate also the standard deviation for this distribution. Right, when we're looking at binomial probability distribution, what we should remember is the identification of the key terms. Remember, this is bi, so there are 2 things that are either happening in our question. We can either make the sale or not make the sale. That makes it a binomial probability distribution. So let me first write the formula for binomial probability distribution. So we're going to say Px is equals to NCR multiplied by P multiplied by, we can say Q here, this is to the power of X, and this is to the power of N minus X. So that's our formula. What we should know from our formula is that the N represents the number of observations within that binomial question. C is the combination on the calculator. R or X is what we're looking for. So we can actually say this is X. These are interchangeable, and then this is the probability of the success event to the power of whatever we are looking for, and the Q is 1 minus P. So the probability of success minus P would give us the probability of failure to the power of N minus X. So that being the formula, we read the question. In our reading of the question, we must identify the things. So in this question, Innocentia has a chance of 40% of making the call. P, our P is 40%. Now 40% is 0.4. And then we're also going to identify the other thing that we need. The other thing we need is N. Your N in this case is we're going to make 8 phone calls. And then what is our Q? Our Q is equals to 1 minus P. So this is 1 minus 0.4, which is actually 0.6. So having identified this that we need, we should be able to answer the question through substitution of the formula. But we're going to number the question, and we say A. A requires you to check what is the probability of making fewer than 3 sales. Fewer than 3 sales. So probability of fewer than 3. When we're looking at binomial probability, remember this is a discrete kind of probability. So in essence, I would recommend that you write a number line like 0, 1, 2, 3, 4, 5, 6, 7, and 8. These are our numbers like a number line. So what you're going to say is they say fewer than 3. So that's less than 3. Fewer than 3. Fewer than 3. So it would encompass this kind of counting. So we're looking at the probability of a 0, a 1, and a 2. So that's the probability that we're looking at. So we're going to combine these probabilities. So in terms of combining these probabilities, you should be able to reduce this into a writing of saying this is like saying Px is less than 3. And now this is equals to the probability of a 0 plus a probability of a 1 plus the probability of a 2. So in this case, we're going to work out the 3 probabilities and join them. Remember, your discrete probability distribution always starts with a 0. So we're going to look at Px is equals to a 0. So this would be equals to our n. Our n is 8, and then we're going to say C0 multiplied by 0.4 to the power of what we're looking for is a 0 in this case, multiplied by a 0.6, which is the q to the power of n minus x. N is 8 and x is 0, so this remains to the power of 8. So this is going to give us, this is going to be equals to, so punching in your calculator, you get your answer. Your answer to the nearest 4 is 0.0167. Okay, I'm gonna say to the nearest, so this is gonna turn into an 8 to the nearest. So that's the first part, and then we deal with the next calculation. The next calculation is px is equals to a 1. This is 8c1 multiplied by 0.4 to the power of what? Of a 1 multiplied by 0.6 to the power of, we had n is equals to 8, but now when you're looking for the probability of a 1, this becomes 8 minus 1, so this is equals to the power of 7. That is equals to, we punch into our calculator. Well, if you're someone else, you can play back this and change the figures there, and it should be quicker for you if you do it that way, but it depends on how you want to work it out. 0.08 to the nearest 4, this is 9, and then that becomes a 6 to the 4 decimals. That's the calculation. So px is equals to a 2 would be equals to 8c2 multiplied by 0.4, we change the power to the power of 2, multiplied by a 0.6 to the power of a 6. This is equals to, we can also adjust this and we do our calculation. This is 0.2090. So we've got the individual calculations of the probability of a 0, a 1 and a 2. So all we need to do now is to come here and do the final calculation. So we say the probability of getting cells that are fewer than 3. So px is less than 3 would be equals to your 0.0168 plus 0.0896 plus 0.209. So this would be equals to, that's a 0.3154. So the probability of making cells that are fewer than 3 would be equals to 31.54%. So that's how you combine and solve your A. Let's move to the B side. What is the probability of making exactly 3 sales when you make the phone call? Right, so the probability of making exactly 3 sales would be easy. This is just like your marginal probability. So px is equals to a 3. You're looking for exactly 3, so we just substitute and say, instead of saying n, we can substitute, and we know that our n is equals to 8. So this is 8c3 multiplied by the probability of a 0.4 to the power of a 3 multiplied by a 0.6 to the power of 8 minus 3, that's a 5. So this would be equals to 0.2787. That's the answer for our B. I can simply straight away move into C. Now C says, what is the probability of more than 3 sales? What is the probability of more than 3 sales? So we're going to write this, px is greater than a 3. Right? So before we do any formulas or any substitution, let's assess and check. What are we saying here? We're saying the probability of getting greater than 3. So if we look at our number line, then this is more than 3. More than 3 would not encompass the 3, but would start from 3 and goes this way. So we're supposed to calculate now the probability of 4, 5, 6, 7, and 8. But that sounds more calculations. It sounds a bit more calculations. We've already calculated the probability of a 0, 1, and 2 from our A. So we also calculated our 3 from our B. So using the complementary rule, we know that the probability that it might rain is 40%. The probability that it doesn't rain is going to be 1 minus 40, which is 60%. Same applies in this case. So what we're going to do is to take the numbers that we already have and subtract them from 1. They'll give us the remaining balance of these figures. Because remember, probability has to always come to a 1. So we're going to say 1 minus the probability of a 0 plus a 1 plus a 2 plus a 3. So in simple terms, I'm going to say Px is less than or equals to a 3. So we are going to say this is equals to 1 minus, in essence you're saying the probability of x is equals to a 0 plus the probability of x is equals to a 1 plus the probability of x is equals to a 2 plus the probability of x is equals to a 3. All these added together would give you your answer. So this is equals to 1 minus, we already did the probability calculation of the 0, so I'm just going to check the answers that we already have. So this is equals to a 0.0168 plus the probability of a 1, 0.0896 plus the probability of a 2, 0.209 plus the probability of a 3 that we did last, 0.2787. Now we're going to add all these probabilities up, and they are going to give us from 1, it will give us a 0.9633. That is our final answer that we should get. You should also get the probability of 4, 5, 6, 7, and 8 and check if it corresponds with this. It should, because essentially we took one side. If you go on the other side, you can take the other portion. It should give you equally the same answer here. Right, so that's binomial probability. Moving to D, you are asked to calculate the mean for this probability distribution. So you should know that the mean is referred to as mu, which is equals to your n multiplied by p. So remember, we had our figures written by the corner. Our n was 8 and our probability of making the sale that we were working with 0.4. So this is going to be 8 times 0.4, which is 3.2. That is our average. And then E, it said calculate the standard deviation. The standard deviation is equals to the square root of n multiplied by p multiplied by q. So this is equals to the square root of n. Our n is 8 multiplied by p, 0.4 multiplied by q, 0.6. So this is equals to the square root of 8 times 0.4 times 0.6. The answer that you get there is 1.3856. That's your standard deviation. That's if you're asked to calculate the mean and the standard deviation of a binomial probability distribution. That's the formulas you use, and that's how you would get your answers. If you were asked to calculate the variance, then you just square this. Remember, the variance is equals to the square of the standard deviation.